In algebra, we looked at graphing our quadratics. Again, I'm calling it day 2.5. Nothing new. Still standard form, still vertex form. We're just practicing graphing them again. So a few things I want to talk about. Domain and range. Domain, this is all possible x values for a given function. And range are all possible y values for a given function. Not every function has a complete domain and range. For the most part, the functions that we're going to see, you're allowed to plug in any and all x values. For instance, if we had a linear equation right here, and I allowed this line to go infinite in either direction, it is going to cross over every single x value from here into infinity. It'll cross every negative x value all the way to negative infinity. There's not a single x value that it's going to miss. It doesn't like skip over one section of the x's and just there's nothing there. Every single x is possibility. And that would be true of our y values as well. It's going to continue growing all the way to positive infinity, and it's going to keep growing to negative infinity. But quadratics are a little interesting. Quadratics, we have a parabola. If we allow this parabola to keep going left and right, it's going to hit every single x value. This parabola is just going to keep going and going and going and going and going this way. It's going to keep going and going and going and going and going this way. But for our range, all the possible y values, our parabola is never going to get any y values less than that bottom part of the parabola. That's why our vertex right here, we classified it as the minimum. If our parabola was flipped the other direction, it's classified as a maximum. But that range is not all possible values. Some linear function features. They're always straight lines. Constant slope. Y equals mx plus b. Quadratics, we have two different forms. We have standard form and we have vertex form. Standard form, ax squared plus bx plus c. And I should write this in function form. F of x equals. Vertex form, f of x equals a x minus h quantity squared plus k. So standard form, we found the axis of symmetry. To find our vertex, to graph our parabola. Vertex form, it gives us the vertex. It is positive h and positive k, so we take the opposite of this one, but we keep the same sign on k. So what we're going to do now, we're going to graph two of each, two standard form and two vertex form. Start with standard form because it's the more challenging of them. We're going to go 3x squared plus 18x plus 20. It is f of x. All right, first thing, we're going to find our axis of symmetry. So we're going to take negative b all over to a. That gives us negative 18 all over 3 times 2. That gives us negative 18 over 6, which is negative 3. So here's our axis of symmetry. Find a vertex, we're going to plug that in. Negative 3 squared is 9. 9 times 3 is 27. Minus 54 plus 20. If I do my math correctly, that is negative 7. So our vertex is at negative 3, negative 7. We're going to use our cheater's method here. This first jump is supposed to be 1. The second jump is supposed to be 3. But we're going to remember to multiply by our a value. So this first one is negative 4. This next one is 5. So negative 4, negative 4. Negative 5, 5. We get our symmetrical points. And there is our parabola. Say we've got negative 1/2 x squared plus 4x minus 7. Again, keep getting lazy. I'm not writing my function notation. Find our axis of symmetry. X equals negative b all over 2a. So that's negative 4 all over 2 times negative 1/2. So that's negative 4 over negative 1, which is 4. Plug in 4 into my function. Four squared, 16. 16 divided by negative 2 gives us negative 8. Plus 16 minus 7. If I do my math correctly, I believe that's 1. Make our table. 4, 1, so we've got 3 and 2, 5 and 6. That first jump, supposed to be 1. Second jump, supposed to be 3. Multiply by a negative 1/2. So we really have negative 1.5 and negative 0.5. So 0.5, and then this is negative 1. So 3.5. Negative 2, negative 1. Get our symmetrical points. And there is our parabola. Vertex form, a lot easier. So if we have vertex form, f of x equals 2, x minus 4 quantity squared minus 5. All we have to do is find our vertex, which is always a coordinate point, opposite this number. We keep this same number, 4, negative 5. And then we get to move on into the cheater's method right away. Up by 1, up by 3. Multiply that by our a value. Negative 3 and 3. Our axis of symmetry, of course, goes right through our vertex. Oops, no, right there. I need to work on my parabola drawing skills. And there it is. Last but not least, maybe we've got 5x plus 4 quantity squared plus 2. Vertex, opposite of h. same as k. Then we get to use our cheaters method. I'm going to go this way, 1 and 3. I have to multiply them by 5. So 5 and 15. So this first one is 7. The next one is 20. What is that, 22? We're not able to plot the 22, and that's fine. We're at -3, 7. And we've got this very, very steep